Welcome to BTEC Revision. In today's lesson, we're looking at the Suvat equations. By the end, we should be able to calculate the displacement, velocity, time, or acceleration using the Suvat equations. Here are the four Suvat equations. Equation 1, equation 2, equation 3, and equation 4. Using these Suvat equations, we should be able to calculate either the displacement, and that's S for short, or the initial velocity, which is U for short, the final velocity, and that's V for short, acceleration, and that's A for short, and finally time, and that's T for short. And if I need to work out any variable, let's take V, then in order to work out V, I will have to know the other variables, which are U and acceleration and time. If I know U, let's say that's 10, and I know acceleration, let's say that's 2, and I know the time, let's say that's 5, then I can work out the value for V. And that's going to be, in this case, 20, and the units are meters per second. If you remember in our previous lesson, velocity is measured in meters per second. Looking at the units for all of these variables, displacement is measured in meters, initial velocity is measured in meters per second, final velocity is measured in meters per second, acceleration is meters per second squared, and time is measured in seconds. So you can see here, displacement is the vector version of distance. It is the distance between 2 points, or distance with the direction. U stands for the initial velocity, which is the velocity that the object starts off with. V stands for the final velocity, and that would be the velocity the object ends with. A is the acceleration, which is measuring how the velocity changes, and T is time. We also need to be able to rearrange these equations to work out another variable. For example, let's rearrange equation 1 for the variable time. So in order to do that, we'll take u away from both sides of the equation, which will give us v take away u equals at, and then we'll divide both sides by a to get t by itself. We want to make t the subject. So that's t equals v take away u divided by a. And using this equation, we should be able to calculate time. Now, if you look at another equation, equation 2, we can also calculate time, but we will have to use different variables. So let's rearrange equation 2 for time. And that's going to be t equals 2s divided by u plus v. So if you look at the difference here between these two equations, they are both calculating the time, and that's going to be the same time, and they will do that by using different variables. So looking at both equations, they both use v, they both use u, and the difference here is one uses acceleration, whereas the other one uses time. So in order to work out the question, we'll have to find the appropriate Suvat equation. Now, let's look at some questions here. We'll start off with the question 1. First thing we should do is, if we write down the Suvat equations, so the first one is v equals u plus at, and the next one is s equals half u plus vt. The third one is s equals ut plus a half at squared. And the last one is v squared equals u squared plus 2as. The next thing we should do is we should write down Suvat. So that'd be SUVAT. We write that down vertically down, and we can write down the values we have. It says the object is accelerated uniformly from rest. So that means the starting velocity is going to be 0. So u is 0 here. And it says after 1 second, it has reached 15 meters per second. So the time is 1 second, and it has reached 15 meters per second, meaning the final velocity is 15 meters per second. The question is asking for acceleration. So that's the question. And then we can work out the displacement, but that will be the second part of the question. So you're looking at these values. We'll start off with equation 1, and we'll see if we have all the variables except for the one where we need to work out, and that's going to be A. So we'll look at V. We have V. U, we have that value. A is the question, and T, we have that value. So this is the equation we need to use for this question. So we'll rearrange this for A. That would be V take away U equals AT. Dividing both sides by T gives us a value of A equals V take away U divided by T. And if you remember this from our previous lesson on acceleration, this is the definition for acceleration. Now we can just plug in our values. V is 15, U is 0, and time is 1. So the answer is 15 meters per second squared. So now in our Suvat, we can replace our acceleration with a value of 15 meters per second squared. Now we have another variable, which will make working out the final variable much easier. So we can pretty much use any equation that has the variable s. So I'm going to pick the easiest one. That's going to be the second one. That looks like the easiest. We could also use the third one or the fourth one. But for the second one, it's already rearranged. And it looks like there's less that we need to do for that one. So I'll write S equals a half U plus VT. Okay, just to make sure we have all the variables, we can just check. U is 0, so we have that one. V is 15, and time is 1. So we have all the variables, apart from the one that we want to calculate. So we can use this equation. So let's write in the variables. That's a half, U is 0, V is 15, and T is 1. And that gives us a value of 15 divided by 2, so that's 7.5 meters. Okay, now pause the video here and attempt question 2 and question 3. When we're starting with these questions, I always recommend to write out the Suvat equations. So we can start off with equation 1, V equals U plus AT. Luckily, you don't need to remember these. You have them in your data sheet. S equals a half U plus VT. The third one is S equals UT plus a half AT squared. And the final is V squared equals U squared plus 2AS. Now we can write down Suvat, SUVAT, and we can write down the values we have for that. S, we don't, yes, it's 100 meters. The next variable, accelerated uniform from rest. So that means U is 0, and after a time, 10 seconds. So time is 10 seconds. And we have the displacement. We need to calculate the final velocity. Okay, we don't have acceleration in this case. So let's try from equation 1, right from the beginning. So we want to calculate V, so that's the question. U value, we have. Acceleration, we don't have. So we can't use this one. Let's try the second one. S we have, U we have, V is the question, and t we have. So this is an equation that we can use. So we need to rearrange this for v. So let's start by writing out that equation. S equals a half u plus vt. We need to rearrange this for v. V needs to be the subject. So we multiply both sides by 2. 2s equals u plus vt. Now we can divide both sides by t. That's 2s divided by t equals u plus v. And we can now take away both sides by u. So that gives us a value of 2s divided by t, take away u equals v. Now we can plug in our values. V equals 2 times s, which is 100, divided by time, which is 10, and take away u, which is 0. So that's going to be a value. So that's 200 divided by 10. So that's 20 meters per second. For question 3, we'll do the same thing and write down the Suvat equations. And then we'll write down Suvat, S-U-V-A-T. And we can write down the values for each variable. So an object is decelerated. So the question is acceleration. Okay, so deceleration is how fast the velocity is dropping, whereas acceleration is how fast the acceleration is increasing. So the question is saying is uniformly decelerated from 50 meters per second to 10 meters per second. So from 50, so it started off at 50, so that's u is 50 meters per second, to 10, so that means the final velocity is 10 meters per second, and over a distance of 1 kilometer, so that's 1 km. So of course we want to change that unit to meters, so that's 1,000 meters. Okay, and you should do that straight away before plugging in the values. Okay, and now we can work out acceleration. So that's the question, or in this case, deceleration. So we want to find an equation that has acceleration. So we'll start off with the first one. Okay, we have v, we have u. The question is acceleration, and we don't have time. So we can't use the first one. Now, if you look at the second one, the question is asking for acceleration. So there is no acceleration in that one, so we can't use that one. So let's try equation 3. Okay, but we don't have time, so we can't use that one either. So we're left with 1. So it has to be this one. Let's just check to make sure. So v, we have that value, is 10. U we have, which is 50. And a is the question. And s we have. So yes, this is the equation to use. So let's write this. V squared equals u squared plus 2as. Now we need to make a the subject. So we'll rearrange, take away both sides by u squared, and that will be v squared take away u squared equals 2as. And then we can divide both sides by 2s to make a the subject. So that's a equals v squared take away u squared divided by 2s. Now we can just plug in our values. So that will give us a equals v squared, which we have to be 10 squared, take away u squared, which is 50 squared, divided by 2 times 1,000. And that would give us a value of negative 1.2 meters per second squared. The negative represents deceleration. So now you can plug in a value. Acceleration is negative 1.2 meters per second. Now we have 4, and we need to work out the fifth. That is very easy. We can just choose any one we want here. And I'll just go with the first one. So we need to rearrange that equation to make t the subject. So that would be v take away u equals at, and divide both sides by a, gives us t equals v take away u divided by a. Now we can plug in our values. V is 10, and u is 50, so let's take away 50, and then we'll divide by acceleration, which is negative 1.2. And it's going to give us a value. So it's negative 40 divided by negative 1.2. The negatives cancel out, and that will give us a value. Time equals 33.3 seconds to 3 significant figures. And now pause the video here and attempt this exam question. As with all the other questions, I'll start by writing down the Suvat equations. So we'll start off with the first one, v equals u plus at. The next one is s equals a half u plus vt. The third one is s equals ut plus half at squared. And the last one is v squared equals u squared plus 2as. And we'll write Suvat, S-U-V-A-T. S is 1 kilometer. Okay, and we should convert that straight away. So that's 1,000 meters. Okay, the question, we have initial velocity is 5 kilometers per hour. So we need to convert that to meters per second. So it's going to be 5,000 divided by 1 hour in seconds is 3,600 seconds. And that's going to be a value of 1.389 meters per second. Our final velocity is 100 kilometers per hour. So that's 100,000 divided by 3,600. And that's going to be a value of 27.78 meters per second. And that's all we have. So the question is asking for acceleration. Okay, and we have converted all these units, and we would get marks for this. So make sure, even if you don't know what to do in the question, you would at the very least convert the units to gain some marks. So we need to choose an appropriate equation. So let's start off right from the beginning. So we have v, we have u, we have a, but we don't have t. So you can't use that one. So let's try the next one. And there's not a in there, so we can't use that one. Okay, we can't use the third one because there's no time. So we're left with the last one. Okay, so hopefully you see a pattern here. If we don't have time, then you would want to use the last one usually. The v squared equals u squared plus 2as Suvat equation. So that's the one we use if there's no time in the question. So we'll rearrange this for a. And if you remember from before, acceleration equals v squared, take away u squared, divided by 2s. And we can plug in the values now. So we know v squared is 27.78 squared. Take away u squared, which is 1.389 squared. And that's divided by 2 times s, which is 1,000. And that would give us a value of 0.385 meters per second squared. And that's the end of the lesson. If you'd like to boost your grades, try the quiz questions, and there's lots more resources available at btechrevision.com. See you next lesson.